Kathy here, and welcome to number 3 of series 2. And I'm relaxing here in the green room with Wordley, who you've met before, and I hope you enjoy what's to come and can apply it to thinking of life and your existence, because our existence is all we have, and understanding it better is the only means that we've got to personal development and being able to expand our lives in a meaningful way. So being able to appreciate what's at work and apply those thought processes, if you like, those gems of information to the way we view things and the way we interpret them, is definitely going to be beneficial in the long run to the way we manage ourselves. So I'm going to do some revealing now. Supersystems. Supersystems is what we're going to be looking at today, and it's defined in the dictionaries as a collection of systems that can become so problematic as to fail to identify with itself. So it seems to be that the quantum mechanical world is a very good example of a supersystem. Understandings of particle behaviour, paradoxes in particle behaviour, forces, energies, momentums, and sources thereof, which are relatively unknown in terms of what their foundations actually are. If you look into any explanation of a physics equation relating to quantum mechanics, you'll see the words, if such and such symbol equals whatever, then such and such symbol will be X. And it's that very definition attempt that kind of seems to fall down in the quantum world. It seems to subdivide itself continually to zero, which is why infinities are such a problem in equations, because a lot of the time when physicists pull together these symbols and put them into mathematical language, the reversion to infinity is a problem, because you can't get past infinity, you can't do anything with it. So to get over that, scientists have to renormalize their equations. Supersymmetry, big bone of contention in scientific circles for a long time, because it's not reliable. Sometimes you can get an object that is its own antiparticle, for instance. So if a particle is its own antiparticle, then it's supersymmetric, because conveniently the parameters of each side of the equation balance themselves out, and that's fine. But violation of symmetry occurs all the time, more often in fact. So this creates a real paradox, because the science says X, and if all these parameters are made to fit together, then beautiful equations can result. Those processes of thinking are linear. They're looking down the road of the symbols and the numbers. It's just like the screen in the Matrix of all these things cascading down in front of your eyes. You've got to love this stuff. Okay. So, superposition then. Superposition is The ability or necessity or inevitability of an object being in two states at once, essentially. We know that there's a big wasp's nest in quantum mechanics with regards to observation. When we observe something, it's said we collapse the wave packet. So we create the particle reality, the collapse of the wave packet, by our observation of the things around us. The ability of something to observe something else goes down way, way deeper than things with brains. And we don't know how far down yet. We are not sure because there is no way of measuring how far down observation goes. Whether a particle can observe another particle, whether it's that fundamental as a principle. It's quite possible that it is. But of course, as a provable subject, it's beyond the realms. It's beyond the realms of science. And that really puts science into something of a superposition in its own right. And that really is where we are right now. Right now, quantum mechanics and the whole plethora of sciences connected to it, like microbiology and chemistry and so forth, are at a bit of a crossroads, because new physics has been promised for a long time, but it's not there yet, and it's not. And it's not really making any signs of an appearance either. So the superposition that exists now in the scientific world is one of transition. We're going back a while now, over 100 years, well over 100 years. Where are we going back to? 1930s, 1920s. So yeah, 100 years or so since it came into the field of view at all. Now, 100 years later, we're in a very similar situation to the Newtonian period, when gravity was found to be very different to the way it had been thought of for 2,000 years previously. So that's a long span of time. Superluminary is the ability to travel faster than light, and it's contended in the physics community that nothing can travel faster than light. Light speed is the upper limit of the universe, and beyond that you cannot go. So is that a mathematical thing? Is that why that constant is there? Because it's a mathematical necessity. Does it translate to the real world? Well, we'll see. But it's very important and fixed constant. It's seen as a reliable foundation, of a reliable measurement with which to constrain the behaviour of the universe. So for now, maybe we're stuck with it. This C, Einstein's C in mc squared. It's a constant, and there it will stay. But superluminary is a word to describe beyond that. What's beyond the speed of light? Therefore, this big kind of Q, which relates to the supersystem of quantum mechanics, you've got quarks, the flavour mixing, the colour mixing, QED and QCD. They've got their associated gluons, which are virtual particles sifting in and out of the colour flavour mixing system. Then you've got the electron belt doing what it's doing around the nucleus of the atom, in constant superposition, just as the quarks are. You've got the neutrino field. The neutrinos are shooting through everything from the sun and other cosmic places, playing in the scenery all the time too. What else have you got there? Well, you've got electromagnetism, so there's the photon behaving in all its magnitude of incredible ways, right across the EM field. And where does the photon become the phonon? Where is the point of superposition between light and sound? Music and light. Yeah, well, you know, it's there, isn't it? If it's there to be had, why not bring it in? Why not bring it into the equation? We have some kind of mental correlation with music and light. And what does that tell us? Does it potentially tell us more than what the mathematics might say? Of quarks, electrons, fields, various other particles, tachyons, pions, muons. Oh, and don't forget the tau. Tau neutrino, my favourite object in the universe. So that's it, really. In our context as living creatures, I guess it pays us to look at the depths and breadths of the system in which we live, so that we can appreciate the complexities behind the simplicities of life, and the complexities of life transversely are relatively simple when it comes down to the application. But we have to be able to get a bridge between the two. We're all guilty of taking a narrow field of view towards a particular habit that we have, or problem that keeps recurring, and that's part of human nature. So breaking this apart like an egg and just coming out into a zone that makes sense for us as ordinary people who would like to be able to comprehend and enjoy the exploration of this field that seems to have opened itself to us all. It's exciting, and it's going to lead somewhere. So, I'm not even going to remind you of what to do next, because in a super system, everybody knows. Enjoy. See you soon. Bye.